Hello everyone, and welcome back to the continuation of our modeling analysis and design of a pre-stressed simplified bridge. And of course, for those of you who are just joining, this is part of two video series. One video series is about the modeling of a quick bridge, just to understand Autodesk Structural Bridge Design. And the other video series is our major video series, where in the end, we will be modeling, designing, analyzing, and everything else for a real complicated bridge that is a box girder in 3D space. Of course, in order to do those crazy and complicated things, we need to start simple, so we have this simplified version of an example. Now, in the previous videos, we talked about how to define our beams and how to define our materials, so check out the previous videos if you are new to this. Also check out the playlist I will be linking on the top right, and we also defined our materials. In today's video, we are going to basically define our structure itself and basically show you the beams in all of their 3D glory. We will not be finishing the entire structure this video because it takes time. However, it's going to be a very important video today, so I hope that you enjoy it. And with that being said, sit back, relax, and enjoy the show. Alright, so first things first, we want to define our structure. Now if you click on structure definition, you see some structure geometry here. That's not what we want, because if you click on structure geometry, you will be only able to define a beam. We don't want to define a beam, we want to define a fully fledged bridge. So this structure definition will not help us. The reason why you see this strange simplified structure definition is because if you click on data and select structure type, you have a line beam for the structure type. Now if a line beam is active, this means that your entire bridge is going to be only a beam, which is kind of a simplified version of the beam. I don't want this, I want a fully fledged beam. So this will not help us. I will have to click on data, go to structure type, and click on refined analysis to kind of signalize to Autodesk Structural Bridge that we are going to make us a fully fledged bridge. If you click on refined analysis, it will tell you that we are going to clear some stuff, and this will not be affected. It's very important to note that our materials and design beams shall not be affected. If you click on yes, then it will do some magic tricks behind the scenes. And you can see that the materials are still the same, and the structure beams are still the same. So now you click on structure definition, and we start defining our structure. Now to define our structure, I need to define the lines that comprise the structure. In the end, my ultimate goal is to make a finite element mesh, or to make a mesh that contains the beams and contains the slab. So to do this, I need first of all to draw the center line of the road. Now the road here is a skewed road, so we need to somehow define those skews. Now this is kind of like AutoCAD, but of course here the tools are a little bit more limited, so we need to use some simplification to draw that. Now let's say that this is our 0, 0 point. You can of course not agree with me and choose this to be your 0, 0 point. However, I'm going to choose this to be my 0, 0 point or origin. It's very important that you know the coordinates before you attempt to draw your line. Now, I know that this point is going to be at 1 meter and 6. So this coordinate is going to be 1 and 6. But of course, the question, how do I know that those are going to be the coordinates? The key to understanding the coordinates is to understand the skew angle here. The skew angle here tells you that for the entire 12-meter bridge, you have a 2-meter skew, meaning that at the center, you would have a 1-meter skew. So I know already what the coordinate of this point is, and I know what the coordinate of this point is. The coordinate of this point is this point plus 21 meters for span 1 and 21 meters for span 2, meaning the coordinate of this point is going to be 43 and 6. Now I will not be drawing something like this in the software because there are some numerical accuracy issues when it comes to finite element modeling here. This is not AutoCAD, so it will not autocorrect your little discrepancies. So this is going to be a nightmare to do in a software like this. So what I'm planning to do is I'm planning to draw me a longer line. So I will go back 2 meters here just to make sure that I can trim and extend. I'll go back 2 meters here and start my line from here. And I will go in forward 2 meters and start and end my line here. The 2 meters are also because maybe I want to have a car driving on the bridge. So I want to model it from back, not on the bridge. So I will start my line at -1 and I will end my line at 45 because of numerical analysis issues and because of the bridge car itself. And also, I would have to draw those blue lines. This blue line and the parallels, basically, this one and this one. I will call them support lines. Support lines because the bridge is supported at that line. Now, of course, I will draw one of those support lines, and then I will just offset it, basically. So I would need to draw this support line. And for this support line, I need to know the coordinates. The coordinates of the starting point of the support line are basically 0, 0. That's the origin. And the end of the support line is basically 2 and 12. 2 because 2 meters, that's skew, and 12 because it's a vertical distance. Another thing I need to know is the dimensions or the distances of the carriageway. Because a carriageway is basically the loading area. The carriageway needs you first to define the line, and then you will tell how the offsets look for that line. A carriageway will allow you to define a footway and draw a road and define another footway. Now for that, you would need to know exactly what the offsets are. It seems the offset for the footway is from 4 meters to 5.5 and from negative 4 meters to negative 5.5, whereas the carriageway is from negative 4 to 4. You would think, wait a minute, that's not possible because it doesn't add up to 12. And you are right. If you add 1.5 and 8 and 1.5, you will get 11. You will not get 12. The reason why you don't get 12 is because there is 500 millimeters of barrier being on the bridge. And you can still say that the footway is 2 meters, but this is too conservative because there is no way somebody would be walking on top of the barrier until he is either crazy or he wants to do a circus trick. So in our case, the footway is going to be from 4 to 4.5, also in the negative. So that's our game plan for the geometry. So let's implement this game plan. To implement this game plan, I right-click on the structure and click Add. You can see that the carriageway is grayed out because you cannot draw a carriageway before drawing the center line of the road. So I'll draw me a design line. That's just a helper line that does nothing except define geometry. Now a line can have multiple pieces, by the way. In this case, I only need one piece because I have a linear bridge. However, you could have a linear bridge, a curve, and then another linear bridge, and in this case, you would have to have 3 pieces for the design line. Luckily for us, that's a simplified example, so we need only one design line. That's the reason why we are considering a simplified bridge before we consider our crazy box girder. I'll go here, click the plus button, and then basically define a line segment, because you can define your design line using multiple line segments. I will click a line, click next, starting and ending point, next. For the easting, now easting is the x-coordinate and northing is the y-coordinate. For the easting, we agreed -1, 2, and 6 for the point 1. And point 2, we agreed, I think 45. I think it was 45 and 6. I click next, it gives me a full summary. OK, and we have our design line. You need to click OK here, because if you don't click OK, it will delete everything. I click OK here, and now I have my design line. So if you right-click again on Structure and click Add, you can see that the carriageway option is now available. Because you have defined your design line, now you can define a road on that design line. If you click on carriageway, it will... I think my software is freezing. I think I need to restart my software. I think it froze. Okay, so we're back in business. It seems it was a bug that this form was not showing, so there was an error. Okay, so we are adding now a carriageway. It asks you to choose a design line. Of course, we have only one design line, so I'll choose the design line. Of course, I have a single carriageway, and it asks you to give him the offsets. I'm going to offset the footway to a negative, as we said before, to -4 and -5.5, and here 4 to 5.5. Those are the footways. I will still have to offset my carriageway -4 to 4, and this would have ended my definition of the carriageway. Notice something peculiar. Yes, it puts the footways correctly, but it seems the carriageway are too small. It should cover the entire width of the bridge. The reason behind that is because the lane seems to be 3 meters, and that's why it's not understanding that my carriageway is at 4 meters. I will come back to this later, but for now I will accept that. That's the loading area, and I need to keep this in mind when I define my loads. This will not happen today, so I will leave it as is. Double checking very quickly. Footway is from -4 to -5.5. Carriageway is from -4 to... I think there should be -5.5 just for the sake of consistency. So from -5.5 to -4, that's footway number 1. And then my carriageway is from -4 to 4, and my footway is from 4 to 5.5. Yeah, that should make sense. I click OK now. So I have defined my carriageway. I will save this time because I don't want it to freak out again and to repeat the entire work. Now we need to do our edge lines here. Those are also called support lines. I click here, I go, now this is a design line once again. So I right click on the design line. Design lines are basically just helper lines. They just define some geometry. I click on plus here and select me a line. This time I have said that we needed to start point to be 0, 0 and the end point to be 2 and 12. I click next, there it is. Now I know that there is some extension here. I know that there are some extensions here. We will deal with this in a moment. I click OK and I have my design line. Click OK again and everything is fine. Now this design line will not have a carriageway because it's a helper line. That design line has a carriageway. We need now to do our model because remember we are doing those lines because we want to define our model. Now I will go here. Now I'll go to the structure and right click here and add something. Now this is where things will be added. I will add me a submodel, meaning I will add a model to the structure, asking it or telling it that the span 1 is going to be everything here, and the span 2 is going to be everything here. So we need models for that, meaning that I'm going to translate and modify those lines to become real structural elements. So how do I do a model? Well, there are different types of models. If you right click here and click add, you have 2D model, and you have a general 2D model, and you have a 3D model. The 3D model is something we will do for a 3-dimensional bridge if you have box girder. I will not do this, but a 2D model is something I will be doing. You have two options. You can have a 2D model with z equals 0, or 2D model with z equals something else. Now, because our bridge doesn't have anything in 3D, I will select 2D with a z equals 0 in the global coordinate system. GCS stands for Global Coordinate System. When you click on that, it adds you the model. Now, of course, it asks you how the model would look like because you haven't defined anything for the model. Now, in the model here, I will start defining my submodels. Because I have a 2D model, I need to define my submodels that define each one of those spans. Now, when I click on submodel, it seems I can't do anything. This is a little bit strange, and follow me. To add a submodel, you need first of all to explain to it where the boundary lines are. This is something called construction lines. Construction lines are lines that help you define the model's locations. So if you right-click on 2D submodel, right-click here, click Add, you can see construction lines. Construction lines are like design lines. They are helper lines, with the difference being that the design line can also carry a carriageway. I will click on construction lines now and start defining my construction lines. You can think of construction lines as being the boundaries of a span. All my construction lines are defined parallel or perpendicular to a design line. That's the reason why we needed to start with the design lines, because our construction lines are going to be either parallel or perpendicular to a design line. Now I need to make this smaller. There we go. This is the one. Now let's define our construction lines. The first things first, I need to take this line, which is the support line, and offset it 2 times. Because I have one support line, this blue line, and I need to offset it 2 times. I need to offset it 1 time at 21 meters and 1 time at 42 meters, because those are my edge lines. So let's do this. I'll ask it to make an offset parallel to a design line. If you click on this, it tells you, okay, you want a construction line parallel to a design line, and I want to select design line 2. Because I will take this design line and offset it 2 times. The offset here is at 21 meters. Oh, wait, I made a mistake. Parallel means exactly parallel. I just want to offset it without paralleling, so that's a mistake. Let me just delete it. I want just to offset, but not parallel, because parallel will offset it with the skew. No, I want to offset it east-west, meaning in the positive and negative xy. So what I'm saying is my first offset was incorrect because it was offsetting parallel, meaning it was going this way, the 21 meters. That's not what I want. I want the 21 meters to be in the x-axis. So that's a mistake I did, meaning I need the offset of the east-west of the design line. If you click that again, now you can select design line 2 and offset at 21 meters. And this is exactly what I want. You will have to add another one, same thing, design line 2 at 42 meters. Those are the boundaries. You can see those extensions that we will basically cut, but we will not doing cutting because you can just ignore them. Also, we need the two boundary lines here, one boundary line here, which is this barrier and this barrier. We need those boundary lines. So let's do this. Now those are going to be offsetted from design line 1, and those are north-south offsets, or you can even use parallel offsets. You can use a parallel because north-south offset and parallel offset are the same. I click on parallel offset this time, select design line 1, and the offset is 5.6 and negative 5.6. You would think, wait a minute, why 5.6 and negative 5.6? Because I know that this is the footway. The footway is at 5.5 meters away, but because there's a finite element thing that we will add here later, I will add 5.6. So this is the center line of the finite element I will be adding later. You can also make 5. Now I know what you're thinking. You think, oh my God, is it really going to make a difference? Not really, but it's better to be accurate. Okay, so I would say here negative 5.6. This adds it here. And also I will add me another offset, parallel. And this one is design line 1, and it's at 5.6. So now I have my offsets here. Fantastic. Notice that the offset is slightly more than the footway, which would make sense because the extension of the bridge is going to go beyond the footway. Now we have our construction lines. I click OK. So those are my construction lines. And I will be using the construction lines to draw the slabs. I save my file because I don't want to lose it. I go again to my submodel because we do not have any beams yet. Those are just lines. So far, those are only lines. The only thing that can be considered structurally relevant is design line 1, because design line 1 carries a carriageway that is structurally very relevant because a carriageway is a load. But so far, no beams have been defined at all. Now we need to start defining our beams, so we need to start segmenting this into pieces. I will right-click on the 2D submodel and click Add. I can add a lot of things. And by the way, you don't right-click on structure because then you can add the tree heads. You go into the submodel and then right-click and add a mesh. So we're going to add us a mesh. A mesh is not what you think. We are not gonna make a slab mesh, a finite element mesh. No, we're gonna make a beam mesh, meaning that we are going to select an area and we're going to make multiple beams or multiple lines. Now our mesh is skewed because we're gonna make parallels to those edges. Why? Because our beams are parallel to those edges. Now let's start clicking. You need to be a little bit careful where you click, and it's gonna select the construction lines. That's the reason why we made construction lines in the first place. One click defines this construction line, another click here, another click here. We are going in a counterclockwise fashion, by the way. Once we close it, you can see that immediately you have some lines. Don't be tricked. Those lines are potential beams. They are not beams yet, they are potential beams. Also look at those arrows. Those arrows are the local coordinates of the beams, the local x coordinate of the beam. This will become relevant later. So we have defined our potential beams. However, that's not what we want, because that's not the position of our beams. If you remember, for the positioning of our beams, we agreed that we are going to have a footway beam here. That's one beam, and it's I think its distance was here 0.5 meter. And then I'm going to have a beam every single meter. And from the looks of it, this discretization will not give me the beams I want. So let's try to modify this to get the beams I want. Now, first of all, let me enlist the help of this longitudinal transverse thing. I will set longitudinal to 8 and transverse to 13. Why? Because it somehow kind of resembles this. Not perfectly, but it kind of resembles it. You see, this can become a trial error thing, in which you are trying to move those things to align well with your model here. It still doesn't align, so I will have to basically do it by hand. I will click on equal spacing and select set spacing for the longitudinal, because now I want to tell it exactly how the model looks like. If you click on that, you can set now the spacing in the longitudinal direction. Your beam, your entire bridge is 11.2 meters wide because 5.6 times 2. Does it work if I add a dimension here? Let's see if I add 0.6 here. It doesn't work. Okay, let's see. 2.6. I think it will work. 4.6. So 2 meter spacing now. 6.6. 8.6. And 10.6. Yeah, I think it works. I think we have done it. Another alternative, set the spacing and ask it to be a spacing factor of 0.3 here, a spacing factor of 0.3. Okay, we got the same values here. You see, there are multiple ways of doing the same thing. You can add the dimensions here, or you can just change the spacing factors here. In the end, I want to see those distances because it's very important, because those are our beams. So now we were at potential beams, but now we are at actual beams. I'll click OK now and continue. For the transverse, here I will go to set spacing. I think I will start with a smaller, because look, what happens here is that we will have another, look, for the transverse spacing, you can see that the software seems to be drawing a beam like this here. And meaning that if I have another beam like this, I would have a large spacing here for the finite elements. So I think I will halve the spacing at each edge. The most important factor was the longitudinal. The transverse is just the cherry on top. So I'll say 0.5 here, and I will say 0.5 here to try get something that is relevant to almost rectangular, almost. Not necessarily. Now, don't get me wrong, the transverse spacing is kind of superfluous. The most important spacing was the longitudinal, because those will become our beams. I click OK now, and now I have my mesh. I should call this mesh span 1, so let me just call this span 1. Once again, okay, this is going to be a long video, by the way. That's my first span. There are no beams yet. Those are only potential beams. We will add beams in a moment. However, I will once again continue and right-click on the mesh and add me another mesh. Okay, I need to cancel this. Click on the mesh, see? Right-click on the mesh, add, and add another mesh. This is mesh 2. Oh my God, my software is once again locking up. Something is wrong today with my software. Okay, so back here to business. I right-click, add, and add mesh. I hope it works this time. Okay, there we go. Now here we need to define once again our mesh. So, okay, 1, 2, 3, and 4. So we have our mesh. Now, do we need to repeat the same steps again? No, because I can copy stuff. Instead of doing the things again, I just can click on copy and ask it to copy from mesh 1 just to get it right. You can see why the half was done here, because it seems that those are too equalish. So this blocks or this block is going to be equal in size to all the other blocks. That's the reason why in the transverse we added a half here. Now, it's not really that critical, but it makes more sense to have, in the finite element mesh sense, to have a uniform mesh. Remember, those are potential beams, not all of them will become beams. I click OK now and save again, because if there is anything I learned today, is I learned that I will keep saving because it keeps crashing on me. Fantastic. Now here, I forgot, I think I should rename this to mesh 1 or span 1. And I should rename this to span 2 because I want it to, make sense. Now we are approaching our beams, by the way. But before that, I need to talk about supports. Those are called span end lines, and then we will define support lines on the end lines. The software needs to know where the span starts and where the span ends, and then we can add supports on those ends. So if you go to the bridge, I right-click here, add, and add something called span end lines. If you click on that, something is totally wrong here. Okay, so we're back in business. I don't know exactly what's happening here. I'm really flabbergasted, but okay, I right-click, add, and add span end lines. And now it's working, I guess. We want to add our span end lines. We can define our span end lines by basically pushing the plus button, because you know that you can add anything with a plus button, or you can just use the cursor to draw a span end line. For example, let me just move here a little bit and be careful in where I click, and click here. There we go. And now I will be careful and try to click correctly. There we go. That's one span end line. and so on. The other span end line is here. Careful where I click. And by the way, there is a snap option. You can see how the cursor is jumping sporadically to snap to the nearest intersection. There we go. We have our 3 span end lines. So now the software knows that we have 3 span end lines for our bridge. I click OK and save immediately because something is wrong with my software today. Now here, since we have our span end lines, it is time to add more supports. Because how can you support a mid-span? You need to have a span end line for supports. So if you right-click here and add, you can see supported nodes. If you click on that, you can add supports. Now, how do you add supports? You can add supports by uniform or by variable. You are now creating supports. If you see here, you can see that you are creating supports. Where are you creating supports? Along span end lines. That's why it was important to define span end lines. It makes your life easier. You can define on joins, but that doesn't make sense. Allow me to show you. If you click on all joins and then select or draw a box like this, then you are defining supports on every node you're touching. Now, this is not what we do. It's actually a misery. So I will click on remove again, or I just click on negative here to delete them all. I once again click here and I remove them. So we're not going to add supports on all joins. We're going to add supports on span end lines. Now here, you could add, and look at this. If you select this, it will select all the span end lines. And because you have uniform, all of them will have the same setting. For example, if you select this and call it free, all the supports on the span end line will be free. This is cool if you have various supporting conditions at various piers. You could have pier number 1, which is free in everywhere. Pier number 2, which is not free in anywhere because it's rigid. And pier number 3, which is free in everywhere. I will delete again, and I will do something different. Here, my supports, all of them, except 2, have only Z, so they are rollers. So what I'll be doing is, I will click uniform, click everything. Wait, I don't want to remove. Yeah, sure. I don't want to, okay, fine, relax. I don't want to remove, I want to create. If you create like this, now all of those supports are being grouped in one group. Okay? You could say, no, I want to have this to be a group, and that to be a group, and that to be a group, and you can do this. I will select all span end lines, as you can see, and I will call for free in X, free in Y, and fixed in Z. So all of them are rollers. Of course, your error sensors should be tingling, because if you follow my robot series, which I'll be linking on the top right, you know that this structure is unstable now. It's a skateboard. You have rollers everywhere. So that's unstable. Now, luckily for us, we have an abutment here, and we have an abutment here. Abutments provide support in the X and Y direction. And I don't want to provide support on all the nodes. I will just provide support on one of them. So I will select this node and ask it to provide me a support in the XY, and select this node and add me a support in the XY. Let me show you what I mean. You see, now after I defined everything, I can click on variable, and I can select a certain node. Let's select this node. When I select this node, it gets highlighted, and I want this to be a pin. So this is not moving, and that's not moving. Now this structure is still unstable, because now you have only a pin here, which means it can rotate around the pin. I need another pin in the opposite side, which is here. I select it, I select here pin, or fix, sorry, and here fix. So I have two restraints, XYZ fixed in this domain, and XYZ fixed in that domain. With that being said, I click OK, and I would have defined my supports. I will save, because the software is unstable, it seems. And then, finally, comes the cherry on top. We have defined our structural model, but we haven't defined any sections. So far, if you click on this thing, there's this box here. I don't know what it's called. I think it's called 3D Elements View. If you click on it, you cannot see any beams. However, you can see some supports. You can also notice that this support is a little bit more because I ask it to stop all the movements. However, the other ones only have one movement support. Okay, so it seems so far everything is fine. However, I don't have any beams. So I defined my structure, but I still need to define my beams. How do I do this? Well, I will stop talking about the structure and I will go to something called, first of all, I will close this. Now I will stop talking about my structure, and now I will go something to the structure properties. This is where I define the beams for the lines. If you click on structure properties, you can see your potential beams. This is the mesh. And remember, I was calling them potential beams. Now it's time to make the potential beams become beams. So in the structure properties, I will say first, I will right click here, click add, and add me a design beam. If I click add design beam, it asks me, okay, you want a design beam, tell me what you want. Now notice I can select different sections because I defined those sections before. Look, if I cancel, those are my design beams, and you can see that those beams have been defined before. So when I go to structure properties and right click and click add, hoping that it doesn't break down on me, design beam. And by the way, when you add a design beam, you are going to select from the pool of design beams. If you add design section, you are going to select from the pool of design sections. It's empty, but this will change in the future. I once again click on structure properties, right click here, add, and ask him to add me a design beam. Here, I don't want a gross section, I want a transformed section. I want a transformed section because I have a beam and a slab of different materials, so he must calculate the transformed section, and this is something from mechanics of materials. If you have a section that has two different material types, like this material type and that material type, then the transformed section modifies the weaker material to become the same strength as the stronger material by calculating N. Please check out the mechanics of material books for more details on transformed sections. You will find this in the chapter of bending when it talks about reinforced concrete, allowable stress design or something. So yes, I want him to do this, which means I will select transformed section. If you select gross section, then he will assume that he will not change anything. You can, and a fun fact here is, if the slab and the beam have the same material, then the transformed section and the gross section are going to be the same, because in the transformed section, nothing will change. Here, you have a cracked section, and by cracked section, I mean, now look, this is our section, right? We have a slab and we have a beam. Now the beam is a pre-stressed beam, so the cracking will be limited because we will see this in the future, but the stresses are controlled in such a way to not exceed the cracking stress of concrete for the pre-stressed beam. However, for the slab, you have simple reinforced concrete, meaning that the slab might crack. Now, when does the slab crack? The slab cracks if you have a negative moment, or as they call it, I think it's called a hogging moment. If you have, because that's our bridge now, that's what you will have for moment diagram in a bridge. This location is the location where the slab is going to crack. Those locations are locations where the slab is under compression and will not crack. Now, we don't know exactly where this is, to be honest. We have no idea because it depends on the spans, it depends on the truck. There are a lot of different things that are to be considered when we talk about a cracked section. So the best option we can have is to predict. I'm going to predict that 15% of the span is going to be cracked. That's a prediction. I might be right, I might be wrong. I have no idea as of now. Of course, I'm not talking about this place at all, because in this place, no cracking to the slab will happen. So, okay, while I'm defining, I'm going to tell him that from the right, at a proportion of 15%, there will be a cracked section. Now, my reference point is not going to be the center of the section, it's going to be the origin of the section. And okay, now I have to assign beams. I simply click on 1, 2, 3, 4, and okay. And the magic has happened. You have 4 beams for the inner span. Now I will save first of all. And if I want to show them, you can click on this 3D view, or Control M, and then you can see them in 3D glory. And you can start seeing that the bridge is taking shape. Like this should cause joy in your heart. Still, you can see that in this place there is no slab. You would think that's a bug, but it's not. I asked him specifically to consider a cracked section at 15% from the right side, because I am predicting negative moments in that location. So the slab now is dead because it's on the cracked section and it will not constitute anything to the transformed section. It's just basically not here. Now we're not finished. We still need to continue this multiple times. I will show you how I will do the north and south and then the rest I will do in a quick manner. Let's add the north and south edges. I will go once again to my section properties, structure properties. I will right click here, add, and ask him to add the design beam. The software is not crashing on me. That's a good indication. This is going to be my outer north span 1. Notice, remember we made multiple spans because of the construction stages. I will click on that. Now, once again, it's a transform section. It's going to be cracked at 15%. It's going to be from the origin. I'm going to select not this, because this is the edge. I will also select this. You would think, wait a minute, it's north. You shouldn't select that. You might have messed up. Let's see what happens. If you click OK now, your error sensors should be tingling, because how are you asking for north and select north and south? Doesn't make any sense. And you are right. If I save and go to the 3D view, you can see something good and something bad. You can see that this has taken a good shape, but that is totally awkward. This is flipped. Now, how do we address this issue? You can define a new section in your beam section or design beams. You can define a new design beam if you want, and then apply it, but that's a waste of time. And here is where the local coordinates come into play. If you remember, long ago, in the structure definition, under the meshes, if you click on, for example, mesh 1 span, so you are in structure definition, mesh 1 span, you can see those little arrows. Now, those arrows are the local x coordinate of the beam, meaning the beam starts from here and ends at here. This local coordinate is also what you see in the design beam definition. You can see that it tells you what the local coordinate of the x is for the beam. And for the north, you can see that the local x coordinate looks like this. What happens if we flip the x coordinate? If we flip the x coordinate, we will be seeing it from a different domain. We will be seeing it, if we flip, you would see this. Exactly. If you flip your x-axis, you would see a perfectly defined beam exactly as you want it. Now, we cannot flip the local x-axis, but what we can do is we can, in our structure definition, in the mesh, we can flip the x-axis of this beam. How do I do that? It's not really that hard, by the way. All I have to do is, first of all, I'm going to cancel this, those beams are defined somewhere. Let me see. Where are the beams? Yeah, there we go. When we mesh, we have longitudinal beams and transverse beams. So we want this beam to be flipped. So I click on longitudinal beams, and it shows me the beams with their, basically their local x-axis. I will select one beam, so I selected it, and now I will reverse order it. Reverse order means it flips its direction. I will do the other one for good measure because I need it in the other span. Now I reverse the order, meaning the x is going to be from here to here, which will in turn flip the section in the section properties, which will in turn flip the section in the full structure. Let me show you. If you go to structure properties, let me save this and show the 3D. You can see that the beams are now fixed. I think I messed something up here. Oh yeah, because this is going to be annoying. Because I told them from the right side, so now this is the right side. Okay, that's easy. I click on outer north span and ask the crack section to be from the left. So I'm just mirroring it. I should have known this. And will it work? I don't think it will work. In fact, no, it will not work because we'll flip both now, right? Let's see. Will it flip both? Yeah, it flipped both. It doesn't work. Okay, fine. It's going to be annoying, right? Okay, let me just try again. First of all, I'll put this back to 0 and 0.15. Okay, so now this is the problem, right? This is the problem now. And how do I fix the problem? I think I have an idea. First of all, for the north span here, I want only to be L2. L7 is not included, so this is not included now. Okay, so now this has no section. If you go to the structure, you can see it's empty. And now I'm going to add something that makes sense. So let's see. I click here and right-click, add design beam. I should do it off screen, but let's see. Outer north span. I cannot call it the same name. I'll call it here 1, 2 or something. And now I think I will do this. Let me see if this works. And select this one. Now, if my calculations are correct, this should work. Let me save. Let's see. Yeah, there we go. Wait, there's something wrong here. What's happening here? There's something totally wrong. Oh yeah, I know. I think I clicked origin. Yeah, I need origin. Yeah, I need origin. So I was like having the centroid, I want the origin, because everything is related to the origin. And once again, let's take a look. Okay, now it's going. Perfect. Now we have our span 1. I will do the same for span 2. So yeah, that's everything I wanted to talk about today. I hope you enjoyed. And before I finish, I want to give a partial defined sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as the support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on. Especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.